Section 6.4, example 4, graphing a horizontal shift of the parent function y is equal to log base b of x. Sketch the horizontal shift of f of x is equal to log base 3 x minus 2 alongside its parent function. Include the key points and asymptotes on the graph. State domain, range, and asymptote. All right, so the parent function here is whatever graph we have here without any shifts or translations. So here, if we were to remove our shift here, we would just have log base 3 of x. So parent function is just going to be log base 3 of x. And let's get a graph for our parent function. So here we have our 5 points. And just like we did before, let's think about the output and then come up with an input. So we'll start with an output of 0. So we'll say 3 to the power 0 gives us what? It'll be 1. So 3 to the power 0. Well, 3 to the power 0 gives us 1. And let's go down. So -1. So we have an output of -1. And we say 3 to the power of -1 gives us, this here is 1/3. And let's try -2, output of -2. So 3 to the power of -2 gives us 1/9. 1/9. And let's go in the opposite direction. So we have -2, -1, 0. Let's try 1 and 2. 1. We have 1 over here. 3 to the power of 1 is equal to, so what's our input here? 3. And let's try +2. So we have 2 over here. 3 to the power 2 is equal to 9. So we input 9. And this is the graph for the parent function. So I'm going to graph our parent function in gray. So parent function in gray. All right, so let's input 9 and output 2. So we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9. And we output 1, 2. And next we'll do input 3, output 1. 1, 2, 3, output 1. Next is 1, 3. So input 1, output 0. 1/3, -1. So at 1/3, we have -1. And 1/9, -2. So here we have our graph. We have that vertical asymptote. Of x equals 0. This was our graph of not f of x, but p of x, our parent function. And now let's do our actual graph in this form. So in blue. So we'll have f of x is equal to log base 3 of x minus 2. Log base 3 of x minus 2. So we have our inputs. And here what we did is we moved our input left 2 units, or I'm sorry, right 2 units. So our input, we're adding 2 to it. So let's start with 9, just so you could kind of see it a little bit better. We're adding 2 to each of our inputs. So 9 plus 2. So here we have 9 plus 2. That gives us 11. And now let's see what we have here. Log base 3 of 11 minus 2, we'll say is equal to x, or is equal to y. That's going to be log base 3 of 9. And we ask 3 to what power will give us 9. So 3 to the power 2 will give us 9. And notice it's very similar to what we have here. As long as we add 2 to each of our inputs, we're going to get the exact same output. So here we have 3 plus 2 will give us 5. 1 plus 2 will give us 3. 1/3 plus 2. So 2, 6, that's a 7 over 3. 9 plus 2, 18. That'll be 19 over 9. And there we go. So here, this should still be 1, this should still be 0, this should still be -1 and -2. And let's see what this graph gives us. So when we input 11, so 9, 10, and 11, we output 2. When we input 5, 3, 4, 5, we output 1. When we input 3, we output 0. When we input 7 over 3, let's see what our graph or the calculator gives us for 7 over 3. So 2.33. 2.33 is about here. And lastly, 19 over 9. 2.11. Really, really close to 2. So our graph does something like this, with the vertical asymptote going through x equals 2. And there we go. So lastly, we just graphed it with our key points, state, domain, range, and asymptote. So for this one, our domain, our range, and asymptote. So domain, again, is whenever we have positive numbers in here. So positive numbers inside of our log are going to be from 2 to infinity. Our range is always going to be all real numbers when it comes to logarithmic functions. So from -infinity to infinity. Or you could just do the all real number symbol. And lastly, asymptote. Here we said x is equal to 2 is our asymptote. And there we go. If you have any questions, please feel free to ask. Try to get everything in that page. If you have any questions, please feel free to ask. Otherwise, bye.